morning, students. I am Dr.R.Suganya, Computer Science with Cybersecurity. Today we are going to see about digital signature. What is digital signature? The digital signature is a technique which is used to validate the authenticity and integrity of the message. There are four aspects of security: privacy, authentication, integrity, and non-repudiation. We have already discussed the first aspects of security, and other three aspects it can be achieved by using a digital signature. The basic idea behind the digital signature is to sign a document. When we send a document electronically, we can also sign it. We can sign a document in two ways: to sign a whole document and to sign a digest. Model of digital signature. As mentioned earlier, the digital signature scheme is based on public cryptography. The model of digital signature scheme is depicted in the following illustration. We can see here the signer and the verifier. So the signer, they have the data that has been used by using hashing function, and again uses by the signature algorithm, and it has been private key is being used, and from that signature algorithm the signature has been verified by the signer's public key, and it is checks whether it is equal or not by using the hash functions. So here the following point explains the entire process, that is, each person adopting the scheme has a public and private key pair. So generally the key pairs used for encryption and decryption, that is signing and verifying, are different. So the private key used for signing is referred to as the signature key, and the public key is known as a verification key. So signer feeds the data to the hash function, and it generates a hash of data. Hash value and signature key are then fed to the signature algorithm, which produces a digital signature on given hash. Signature is appended to the data, and then both are sent to the verifier. Verifier feeds a digital signature and the verification key into verification algorithm. The verification algorithm gives some value as output. Verifier also runs same hash functions on received data to generate the hash value. For verification, this hash value and output of verification algorithm are compared. Based on the comparison result, the verifier decides whether the digital signature is valid. Since digital signature is created by private key of signer and no one else can have this key, the signer cannot repudiate signing the data in future. Importance of digital signature. Apart from ability to provide non-repudiation of message, the digital signature also provides message authentication and data integrity. Let us briefly see how this has been achieved by the digital signature. Message authentication. When the verifier validates the digital signature using public key of a sender, it is assured that the signature has been created only by the sender, who possesses a corresponding secret private key, and no one else. Data integrity. In case an attacker has access to the data and modifies it, the digital signature verification at receiver end fails. The hash of modified data and the output provided by the verification algorithm will not match. Hence, receiver can safely deny the message, assuming that data integrity has been breached. Non-repudiation. Since it is assumed that only the signer has a knowledge of the signature key, he can only create unique signature on a given data. Thus, the receiver can present data and digital signature to a third party as evidence if any dispute arises in future. Encryption with digital signature. So we have seen already about what is encryption. So in many digital communication, it is desirable to exchange an encrypted messages, that is plain text, to achieve confidentiality. So in public key encryption scheme, a public key of the sender is available in open domain, and hence anyone can spoof his identity and send any encrypted message to the receiver. This makes it essential for users employing PKC, that is for encryption, to seek digital signature along with encrypted data to be assured of message authentication and non-repudiation. So this can achieved by combining the digital signature. So we have how we can achieve with two possibilities like sign like encrypt and encrypt then sign. So however, the crypto system based on sign then encrypt can be exploited by receiver to spoof identity of sender and send that data to third party. Hence this method is not preferred. The process of encrypt then sign is more reliable and widely adopted. This is depicted in the following illustration. In sender's side, encryption using receiver's public key, hashing function, and digital signature with sender's private key. So here we can see the encryption, which is uses a public key, and here the digital signature with sender's private key. So it uses both the keys. So the receiver, after receiving the encrypted data and signature, verifies signature using sender's public key. After ensuring the validity of the signature, it retrieves the data through encryption using private key. The most distinct feature of public key infrastructure is that it uses a pair of keys to achieve the underlying security service. Since public keys are in open domain, they are likely to be abused. So to establish and maintain some kind of trusted infrastructure to manage these keys. Thank you.